We're going to need to make a sort for our ascending, which we would print out here, and then a sort for our descending. We're also going to need to actually print these out. So what we can do is make a private method in our Radix class, which will be like a toString, and it'll print this out as a string. And then we are going to need another helper method, but we'll get to that in a second. So for ascending order, what we can do is say, well, we're going to want to print something. We're just going to do a sysout. So this is going to be void. We don't need to store it in anything. All we need to do is radix, and then we are going to do dot, and then we're going to say sort A for ascending. So we have sort A, and then we're going to pass in our array, and then we're going to pass in our max base. So we're going to do int arr, and then we're going to also pass in the max base. And then we can come outside of here and end this line. We're going to do the same thing for the sort in descending order. Remember, because for descending, all we're doing is we're going to take what we have here. The only difference is that we are going to be printing it in the opposite order. So we'll just change that little bit in our code. So we have these two written out, and we can hover over it. We'll create a sort A method, and then we can create a sort D method. And then I just realized we don't need to pass in the type when we're pushing parameters into these methods. So we can come down here and we can see that it is implemented right here. Since this happened afterwards, I'm going to cut this and I'll bring it below right here. So we have our sort A, well, we have our sort D and sort A, but we'll just rearrange them so it's in order. So we have sort A, and then we have sort D. So for sort A, we're going to print out our prompt first. We're just going to have a sysout, and then we are going to in here write radix sort in ascending order. So this is going to be our string, the prompt kind of. And then after this is where we're going to use the queue. So we are creating a queue for 10 buckets because a radix is from 0 to 9. So we have queue, we have these brackets, and we have our array here. And this bracket is basically saying, well, we're going to make a new queue, and we're passing in 10 indexes in here. And then after this, we're going to add our buckets. So we're going to write adding buckets 0 through 9 into the queue. Because above this, we've only made a queue. We haven't put anything inside of it. We've made 10 queues, but we don't have anything inside of it. So inside of here, we're just going to have a for loop that'll go 10 times. We're going to say int a is equal to 0. We need to start a at 0 because, well, we're looking at indexes. And we're starting at the first part. And we're going to do a++. And then inside of here, we're going to do a queue array. And then we're going to set this equal to, actually, we're not going to set it equal. We need to get the position of our queue. And we're going to set it equal to a new queue. So when this runs, 0th time, we're making a 0th one. And then we're making a 1, 1, 2, 3, 4, 5, 6, 7, 8. Until we hit 9, and that will take up all of the queues in our queue. And so that will be that. Now what we're going to want to do is filling the buckets. We're going through the powers of 10. And so we're going to do this with a for loop. We're going to say for, and then we're going to have an int. We're just going to write power of 10. It's pretty fitting. We're going to set it equal to 1 first, and that's because, well, we're going to start off with 1. We're going to say this is going to run as long as power of 10 is less than or equal to our max base, because we don't want to go over this. We just want to be less than, but also we can be equal to. Actually, we want to be equal to, basically. We want to run this entire for loop as long as this is less than our max base, and then we're going to stop it at the max base, but run it while it's equal to our max base. And then we're going to say power of 10, and we're not going to do plus here, we're just going to do times equals. And so basically we're saying power of 10 is equal to power of 10 times 10 because, well, it's the power of 10. And then we're going to be inside of this for loop. inside of this for loop, we're going to be examining the values in the array. So in examining the values, well, we need to examine all of them. And so we're going to run this for loop for int a is equal to 0, and then we're going to do a is less than array dot length, because we want to run this the entire time. And actually, I just realized that for our sort A and our sort B, it says we're passing in an object, but I meant to be passing in this integer. And so I guess the problem is that instead of just passing in ARR, we can't do that. Well, we can. The problem is that when Eclipse, because we hovered over it and we made it auto-generate a function, Eclipse thought of it as an object. So this needs to be an int, and we'll just say that this is ARR. And then the same thing for this. I guess that's really good to catch, because sometimes Eclipse in their auto generation might make a mistake there. So now that these are both ints, we can compare these properly. We're going to do ARR dot length, and so we're going to run this as long as it's less than length, and we're going to do a plus plus, and then we're going to be inside of our for loop. And then inside of our for loop, there's a few things that, well, we're actually going to be only in this for loop for a second, and then we're going to break out of it, go back to this outer for loop, and then we're going to write below it. So inside of this for loop, we're going to be queuing into the array whatever digit we currently have. So inside of here, we have int digit, and this is equal to get digit. And so inside of here, we're going to have our array, and then we're also going to be passing in our power of 10. And this will become familiar with Radix Sort, because when we make a queue, we have to make it for the first power of 10, and that's why this is the outermost for loop, because we're doing it one time, and then we're going to sort everything to that first base. And then we run this again, and then it's the second base. So it's going to be the second slot. So if we have like 1, 2, 3, comma 4, 5, 6, first time this goes through, we're sorting this with this last digit in mind. Then the next base has this last 56 digit in mind, and then the next one has this 456 in mind, and then so on and so forth, and that will help us sort it. So that's what this is going to do. We are going to have to create a method for this. I didn't mean to write ARR here as well. So we're going to hover over this, and we're going to click create method, get digit, and this will make us our method. So what we can do, since we were actually going to use this for our sort D and our sort A, since we are using it for the sort A, we can paste it down here. It's private because we're only using it in our sort A and our sort D, and so we can now write inside of here. All we're going to be doing is returning the number divided by the power of 10 that we're passing in, and take the modulus of it. This will give us whatever kind of quote-unquote remainder that we have. So we'll just say, well, we have our number, which is I, because it auto-generated it as I, so we'll just go with it. We're dividing this by the power of 10, and then we are going to take the modulus of this result, 10. And we're just going to return that. And so if we had like 1, 2, 3, 4, 5, 6 again, if we have 1 as the power right here, well, we're going to do I divided by 1. So we're going to get 1, 2, 3, 4, 5, 6. The modulus of this is 6. So we're going to sort it in the 6th queue. Next, we do this again. The power of 10 is 10. And then we have 1, 2, 3, 4, 5, 6 divided by 10. The modulus of this will be this 56. And then so on and so forth. So we can see how that would get more sorted as we go. So inside of here, we're going to need to store this in a queue. And this queue is this one. Now we're going to go back inside of here, and we're going to add these values to the queue. And so what we're going to do is we're going to have queue array, and then we're going to have the index of whatever our digit is, and then we're going to dot NQ, this will add it to our queue, because remember, NQ is adding. And then I don't know why there's an A here, must have mistyped, but we should have an array of whatever A we're currently looking at. And I think this array should be ARR. So we have this int digit, and it's equal, I don't know why there's a brackets here either, or braces, but we should have this int digit, here we go, is equal to get digit, and we're passing these parameters. This will call this method and get the digit there. And then we're going to say that the queue array, we have this digit, whatever digit we have, and then we're going to enqueue this into that array. So this creates the queue, this creates the buckets in our queue, the queue and queues, and then we are going to be basically filling our buckets with this for loop, and then this for loop, because this outer for loop is basically running for every single base that we have, every to the power of 10 that we have. And then we have this for loop, which is going to examine all of the values, and it's going to enqueue them inside of here. And then after we do this, we are going to break out of this loop. So we'll come down beneath it. We're going to make an integer, int item is equal to 0, and this will become clear in a second. And then from here, what we're going to do is we're going to have another for loop, and then we're going to do ints, and then to be specific, we'll call this queue number, and we'll set this equal to 0. And this is the queue num that we're looking at. So the queue number is less than 10, because 10 is how many queues we have, because this is going from 0 to 9, so the length is 10. And then we're going to say, well, we have queue num plus plus, and then we're going to be in these braces, and then inside of here we're going to have another for loop. We're looking at this item part right here, so we're just going to block this off since we've already declared it, and then we're going to run this as long as our queue array is not empty, which is where the is not empty came in, where we created that earlier. We're going to have, well, queue array, we're going to look at the queue num index, and this is running as long as it is dot not empty, so we're going to say dot is empty, if I can spell that correctly. We have that spelled wrong, and then I think that was spelled wrong, so then we can have our dot is empty, and then we're just going to do item plus plus, and then we're going to be inside of our for loop, and inside of our for loop what we're going to do is realize that I thought I said queue num. I guess I must have miscorrected that when I tried to correct that. Inside of our for loop, we are going to have the array ARR. We are going to have the item, and this item, remember we declared it up here, is equal to, and then we are going to have queue array dot, and then we are going to have, or not queue array, sorry, we're going to have queue array, and then we want to get the actual index of what we're looking at. So we're going to do queue array, we are going to do queue num, because this is the outer index we're looking at, because remember we're basically pulling everything out of our bucket now, and we are putting it in here, and so queue num, and then we're going to do dot dequeue. So this will remove it from our queue, and that's it. We've dequeued it. And so that is going to be the dequeuing. And so that kind of like sorts it back into the array here. And we'll go over that when we do it in the sort D, because it's very similar. But this is how we would write out sort A. And sort D, the only difference is the last part. The last part is because we're doing this in reverse. But going over the sort A, we have this radix sort in ascending order. We have this queue, which will create the queue for the 10 buckets. We are going to add bucket 0 to 9 for the queue, and so this is a constant time. We are then going to fill the buckets, and this all happens in here. And so we're going to run through this as long as our max base has max in it. Once that maxes out, we're going to break out of this for loop, but inside of here, we're going to examine the values in our array. We are going to get the digit of each value, and then we're going to enqueue it into our queue based on the digit of the queue, based on the digit of the value at that index. And then we're going to have int item, and then we're basically going to be pushing this back into our array so that we can look at this all over again. Once we have all that done, all we got to do is print it. So we need to make our toString method, and that will be done in the next part with sort D